Hello, this is Geometry A. This is Unit 7, Lesson 2, Perpendicular and Angle Bisectors. You may notice I have a copy of GeoGebra open. That's an online application that's really fun to use. We've used it in a couple of our demonstrations and in one of our portfolios so far this year. So it's geogebra.org/geometry. If you're interested in following along in GeoGebra, I recommend it. Okay. We're looking at perpendicular bisectors and angle bisectors and some of the properties associated with them. So I'm going to start with by drawing a line segment using the segment tool, and then using the construct tool and the perpendicular bisector tool, constructing a perpendicular bisector. I'm going to go ahead and put a point C on there, right at the midpoint. So AC is congruent to BC, and the angle formed by the line and the line segment is 90 degrees, perpendicular right angle, right? And I'm going to take, with my point tool, I'm going to put a point on the perpendicular bisector, and I'm going to measure the distance between that point and the end points of the original segment. So to do that, I'm going to draw the segments, DA and DB, and then I'm going to use the measure tool in measuring distance or length to measure the distance or length. And looks like they're both 7.3. Let's move them off a little bit here. Okay, and so they are both the same. Now you might ask the question, are they always the same? Both seem to be the same. Well, the cool thing about GeoGebra is I can click on the point D and with the move tool, and I can move things around. 5.8, 5.8, 5.6, 5.6, 7.7, 7.7. 7.8, 7.8, 8.5, 8.5. Even changing the original line segment shouldn't change the fact here. Now it's 9.2, 9.2, 7.7, 7.7, 7.7. Now I'm just going to talk through the reasoning and why this works. This is a perpendicular bisector, so I know AC is congruent to BC. And I know this is a right angle, so I know these two angles are congruent. The triangles also share the segment DC, so by the reflexive property, DC is congruent to DC. And these two triangles, the left and the right one, are congruent by side, angle, side. Since they're congruent, corresponding parts are congruent, and the hypotenuses must also be congruent. So it's always going to work, okay? And I'll leave that proof for an exercise later on. Okay, but that's the big idea. The perpendicular bisector, the rule is any point on the perpendicular bisector is equidistant from the endpoints. Let's write that down. Okay, any point on the perpendicular bisector is equidistant from the endpoints. Okay, now let's explore the angle bisector scenario. Okay, Control A, delete. All right, so let's draw an angle. Okay, so I'm going to place 3 points on the screen here and draw an angle here. I can do an angle, and there should be a ray tool. There used to be. Yeah, there it is, ray tool, underlines, VA, VC. Okay, and I can now go back up here and move, and I can change the angle, etc., right? Doing anything I want with it. All right, now I'm going to use the construct tool, angle bisector. So I'm going to click A, B, and C. There's the angle bisector. I'm going to place a point somewhere on the angle bisector, D. And what I'm interested in is the distance from D to the sides of the original angle. Now that's not as easy to measure as the perpendicular distance, because I can't just draw a line segment connecting the endpoints. A and C are not endpoints. A and C are just random points somewhere on the sides. Distance between a point and a line is perpendicular distance. So I need to draw a perpendicular line. So I'm going to use the construct perpendicular line, click on D and click on BC. And I'm going to click on D and click on BA, right? So D to that is perpendicular, D to that is perpendicular, And I'm going to place a point here on there. Okay. And what's more, just to make things a little clearer, I'm going to redraw a segment between D and E, kind of over the top, and between D and F. And then I'm going to select this line, and I'm going to drop it down to very light here. Just a very small line. Okay, so we're emphasizing the distance, perpendicular distance from D to E, perpendicular distance from D to F. Okay, and now I want to measure. So let's measure distance or length. 4.4, 4.4. Lo and behold, look at that. They're the same. Is that always the case? And as I move it out, 5.5, 5.5, 3.3, 3.3, 1.6, 1.6, 0.7, 0.7. So here's the rule. And actually, let's go to the reason why this works. We have a shared side. So the hypotenuse, BD, of both right triangles is congruent. We have a right angle. Angle E and angle F here are 90-degree angles, so it's a right angle. Okay? And we have an angle bisector. So angle ABD and CBD is congruent. So angle, side. Actually, it's angle, angle, side. Angle, angle, side says the triangles are congruent, so these legs DE and DF are congruent. So there is a reason, and again, I'll leave the proof to you later on. Okay, so here's the rule that we just demonstrated. Any point on the angle bisector is equidistant from the sides of the angle. Okay, so any point on the perpendicular bisector is equidistant from the endpoints. Any point on the angle bisector is equidistant from the sides. And let's demonstrate real quick how that is used in a problem. So let's do it in blue here. Okay, so case 1, perpendicular bisector. You're given a situation where you have 2 points and a line segment drawn between them. And you draw the perpendicular bisector between them. Okay, and you put a point somewhere on the perpendicular bisector. Okay, we know that in this case, these 2 hypotenuses are congruent. So if this is A, or we know, let's do it this way. We know that AC is equal to BC. AC is congruent to BC. AC is equal to BC. Okay? And so we might see it in a problem like this, where we're told this is x plus 4 and this is 2x. We would say then x plus 4 equals 2x, and we would solve for x. All right? Okay? And case number 2, let's say we have an angle bisector here. Okay? Case number 2, so we have some angle. Okay, and an angle bisector. So this is congruent to this. Then we would say we have a point on here. We have the perpendicular distance. And the perpendicular distance, we would say that this segment is congruent to this segment. So the way this would work out here, let's say this is A, B, C, and D. We would say that AD is equal to CD. And if we had an algebraic expression like 3x and x minus 11, we would say then that 3x equals x minus 11. Okay, so hopefully that makes sense. Any point on the perpendicular bisector is equidistant from the endpoints. Any point on the angle bisector is equidistant from the endpoints. And the converse is true as well. If a point is equidistant from the endpoints of a line segment, it is on the perpendicular bisector. And if a point is equidistant from 2 lines, it is on the angle bisector between the lines as well. Okay, so the converse is also true. All right, so hopefully that helps.